So today what we have to do with our add-on, when we're solving equations with variable terms on both sides, every time you solved them yesterday, you got a solution, a one-value solution for the variable, right? Even though there were variable terms on both sides, that didn't mean you got two solutions, did it? You still just get one solution for the variable. Josh, can you say that, please? Thank you. So today, let's start off by talking about a vocab word that's really important, identity. An identity is an equation that is always true no matter what value is substituted in for the variable. So in other words, if you just randomly choose a number and you substitute it in for the variable into the equation, no matter where that variable is, and you evaluate both sides, you're going to end up, it's going to look like a check problem. You're going to end up with a statement that's true. So when that happens, when we have an equation where it does not matter what x is equal to, or n is equal to, or whatever the variable is, or in other words, one side of the equation looks exactly as the other side of the equation, that's where identity comes in. Identical twins pretty much look alike, they're hard to tell apart, right? So identity, one side of the equation is exactly the same as the other side of the equation. When we have that happening, the solution is the set of all real numbers. All real numbers. And by the way, the set of, I want you to circle all real numbers. The set of all real numbers is the whole number line. Every number that resides on the number line is considered a member of the set of all real numbers. Okay, I'm just going to say it one more time. Let everybody put their butts back in their chairs. Sit up for me. Thank you for making me tired. Okay, let's solve a problem. Remember yesterday when we were doing these, first thing we look for is can we do any simplifying? Can we simplify this equation before we solve it? Okay, what can we do? Anything on the left side? Devin?
10 plus 1.
We can add the 10 and the 1. We can add the constants together. So we have 11. No x's to combine with it, so we'll bring down the minus 5x. And then we have anything we can do on the right side? Any simplifying there? Andrew?
7x minus 12x.
We can take the 7x and we can subtract the 12x, and what do we get? Negative 5x.
Plus 11.
And then we bring down our plus 11. Okay. What would we do next to solve this now? Because now it's ready to solve. Is it ready? Okay, what would we do? Nothing? What'd you say, Austin?
I thought it was equal, but it's not.
You thought it was equal, but it's not. Okay, well then what should we do? Let's go about solving it then. Andrew? Subtract what?
11.
Oh, but remember, that might just get us, well, we can do that, but it's just gonna, remember, when we have variable terms on both sides, isn't it best to deal with those first?
Add 5.
So add 5x to both sides, it'll get them off to this side, right? They're being subtracted on that side, so if we add 5x, we gotta come over to the other side and do it also then. And now we're gonna have that 11 by itself, because these guys take care of each other. Oh, wait a minute, these guys took care of each other also, didn't they? And the only thing left is that plus 11, which makes it a positive 11. What do we have here? What's this called now? An identity, isn't it? Yeah. Well, if it's an identity, what did it say the solution is then? All real numbers, so we say solution, because we're not done yet, we're solving this, we have to say, what is the solution? The solution is all real numbers. And we're not going to say any real number, we're going to say all, so that we just include the whole number line. So this would be our final answer. Anybody just happen to know the symbol for that? So we cannot have to write out those words. I like how we use acronyms for a lot of things. Math does that kind of stuff too. Jake, you know it? The equal sign with the lines marked curve is approximately equal to AJ.
Infinity sign.
Well, it could be the infinity sign, but infinity really means it's going on in the positive direction forever. Because there's also such a thing as negative infinity, that goes on in the negative direction forever. So that more describes that, you know, the number line never ends. Here's what it is right here. Double bar, capital R. What a shortcut, huh? That's all. The whole lot easier to write out the words all real numbers, right? Okay, so here's what we want to observe. I want us to write in our notes. The variable eliminated on both sides. It didn't just eliminate on the side we were trying to get it to eliminate on. It eliminated on both sides. And I didn't want a punctuation mark there yet. And left with a constant equal to itself. A constant equal to a constant, and that constant will end up being itself. So when we are solving these, the variable is going to like just disappear. It's going to eliminate. You're going to be like, wait a minute, I was just trying to get rid of them on one side, and now it's going on both sides. And as long as you end up with a constant equal to itself, you can say, oh, this is an identity. This has a solution of all real numbers, the whole number line. Okay. Now, to prove it is an identity, pick a value for x, substitute it into the original equation, and evaluate. So here's what I want you guys to do. I want this whole row. I want you guys to pick something from the negative side of the number line. You just pick your own randomly. Pick a number, substitute it into the equation, and see what you end up with. You guys, I want you guys to pick. And these three over here, you two in front. I want you to pick a positive number, something on the right side of 0 on the number line, and see what happens. And you two, I want you to use one of you to use 0, and the other one I want. So you might have to fight this out. I want the other one to use. How about the fraction 1/2? So, pick a number from what I told you to pick from, substitute it in, and tell me what happens. So what number did you pick?
-2.
Okay, and what happened when you put -2 in? What did you end up with?
21 is equal to
Check, right? Okay, Braden, what did you pick?
-1.
X equals -1, and what did you end up with?
5 equals 4.
5 equals 4. Uh-oh, that means -1's not a solution then, huh? But yet we just said that every number on the number line is, but you just disproved one. Austin, help him up. Make sure he's right. We don't want to throw a -1 on the bus until we need to. AJ, what number did you use?
-4.
-4. And what happened when you put -4 in? What did you end up with?
31 equals 31.
31 equals 31. Well, -4 checks out then. How about you, You use -4 also? -2. And when you get a -2, did you get 21 equals 21? Cool. Okay, Josh?
I did too.
Okay, and what happened when you did 2?
I got 1 equals
1 equals 1. Cool, that one checks out then, doesn't it? Okay, Devin and Andrew, who lost the rock, paper, scissors, who had to use 1/2?
Well, I did 1/2.
Okay.
8 and 1/2 or 8.5 equals 8.5 equals
Okay, I'm sorry. So you got what?
8.5 equals 8.5.
Oh, well, look at there. It checked. Isn't that crazy? Okay, Devin, did 0 check?
Yeah, I got 0 equals 0.
You got 0 equals 0. Huh. Okay. Not surprised about that, but okay. But it checks, right? Okay. I need some positive numbers besides Josh's. Margaret, what did you use?
2.
X equals 2. Oh, well, that's already been used, hasn't it? Did you get 1 equals 1?
Yes.
Yeah? Okay. How about you, TJ? What'd you use?
I used 2.
You used 2. Oh, dear. Caden? 2. What is 2 everybody's favorite number, or what, Shay? Oh, these people that did the positive numbers, they let me down. They all used the same one. Okay, well, Braden, are we still convinced that -4, or -1, excuse me, is not a solution?
No, it's a solution.
Oh, what did you end up with now?
I haven't ended up with anything, but it's a solution.
Oh, you're just convinced it is?
Yeah.
Oh, okay. Well, let's see. I'll help you out here. 5. This is a -5 times a -1. That would be a positive 5. So 10 plus 5 is 15, and 15 plus 1 is 16. Okay. 7 times -1 is -7. Oh, just in case we forget. And this is 11. Let's do this one right here. This is a -12 times a -1. That is a
Positive
Wow.
12.
positive 12, and then we have that plus 11 in there. So let's see. Do we end up with, what did we end up with over here again? I already forget.
16.
You remember 16. Okay. So let's add the 11 and 20 and 12 together. What's that? 23. And then take 7 away from that. What's that?
16.
Oh, look at there. You're right. -1 is the solution because you end up with 16 equals 16. Okay. Did we prove our point? So it does not matter what number you pick from the number line, and when you have an identity, the solution is all real numbers. Now I want to, just before you move on, because I know you're really excited to, before you do, I want you to notice something right back here. I'm going to put a blue arrow here. Was it an identity already right there?
Yes.
Yes.
Because this side can be rewritten as 11 plus -5x, right? Equals -5x plus 11. And when you have addition, they can trade places, so those two could trade places, and looky there. That, they are identical, aren't they?
Yes.
So we had an identity all the way back there before we even finished solving it, didn't we?
Yes.
Yeah. Okay, questions? Okay, is this going to happen every time? No, it's going to happen sometimes, okay? So some equations are always false. In other words, no matter what number you pick for x, you're never going to find one that will make the equation true. So we have to say some equations have a no solution answer. Oh, therefore some equations do not have a, I guess we got to get rid of the word no. So we would say their answer would be no solution. I didn't realize how I'd written that there. So sometimes the answer, instead of being x equals a certain value, or x is any real number, sometimes we're going to have to say, you know what, x is a no solution. Well, let's see what happens in this problem. What can we do? Any simplifying? Okay, what can we simplify?
You can take
12x
Plus x.
Okay, and what does that become?
13x.
13x.
Minus 3
Minus 3.
equals
What can we do on the other side?
5x plus 8x.
Okay, what's that become?
13x minus 4.
Huh. Okay, what would we do next?
Subtract 13 from one side.
Subtract 13x from both sides. Okay, so we got to get rid of them on, if we're concentrating getting rid of them on the left side, we would take them away there. Well, then we got to take them away on the other side. Huh.
Now f of -3 equals -4.
Now we're left with -3 on the left side, and they happen to cancel each other out on that side too, and we end up with -4 on the other side. Is that an identity?
No.
No. So we can't say it's all real numbers. So, in other words, is this true or is this false?
False.
This is false. This is so false. So, when, we're going to put this in our notes, when the variable eliminates, this in your notes please, when the variable eliminates and the constants are not equal, it is no solution. We would not be able to stop until we state that there is no solution to this particular problem. Anybody know what we could put instead of having to write the words no solution? What's an empty set look like? Anybody know? This is an empty set. It's like that. Empty set, no solution. Okay, one more thing we're going to do together because I don't know how these went in the homework, so there were a couple of problems like this in the homework where you had to write an equation to represent the statement and then solve it. So, write an equation to represent the relationship, then solve the equation. A number decreased by 30 is the same as 14 minus 3 times the number. What's the unknown in this?
X.
X. And X is the what? The number. It's that crazy number they're talking about. X is the number. So, is the same as soon as I see those words right there, I think of what?
An equation sign.
An equation sign, an equal sign. And I'm going to take this right here, a number decreased by 30, that's going to be one side of my equation. What can I write for that?
X minus 30.
X minus 30. And then the 14 minus 3 times the number is the other side of the equation. 14 minus 3x. Okay. Solve it. What's the number? Anybody got the number yet?
Yes.
And the number is J? 11. And the number is 11. Okay. Questions at all on our add-on? Is there add-on notes? So in other words, we have 3 possibilities now that can happen when we're solving equations, right? What are they? Andrew, what's one of them?
No solution.
No solution. The second possibility, Josh?
False.
Well, if it's false, that means what for the solution then? No solution. Andrew already showed that one. You don't get to have that one. Sorry. Austin? Pardon? Infinite solutions, which we state as what?
All real numbers.
All real numbers. Okay, so the whole number line, right? An infinite number of solutions. We don't say infinity. We say an infinite number of solutions, or all real numbers. That would be the way to state it. Okay. And what's the third possibility? What would the third possibility be then? Andrew? Just a one-value solution, like it's been happening up till this point, right? Don't forget about those guys. Like x equals 5.